Here's video number 1, and we're going to jump right into the class opener. So on number 1, you need to simplify it. And what do I mean by simplify it? Factor first, then cancel. So when you factor x squared minus 2x minus 15, you could break that down to what? Negative 5 and positive 3, right? Negative 5 times 3 is negative 15. If you combine it together, it is negative 2. And the bottom one, x minus 3, x plus 3. Again, what times what is negative 9? That if I combine together, it gives me nothing because there's no middle term. That'd be a positive 3 and a negative 3. And of course, the plus 3 and plus 3 cancels. There's my final answer. You don't need parentheses around your answer. Okay. Let's move on to number 2. A lot of people got confused with that type of question. Number 2 is simply changing the division to multiplication and flipping the second fraction only. The second fraction only is the only one that flips. So I rewrote the first one. The second one is the one that actually flips. You change to multiplication, x to the 4th up on top, z up on top, and 10xy on the bottom. And now, since there is no addition or subtraction, you could cancel out anything you want on top and bottom. So the 8 on top and the 10 on the bottom are both divisible by 2. So you end up with a 4 up on top and a 5 on the bottom. In addition to that, you could cancel, like, you could do 2 steps in one. What am I saying, or what am I talking about here? Let's look at the x's. For example, there's an x down here, and there's also another x down here. You guys see both of these x's? Yes. Okay. So there's 2 x's down here, and there's actually 2 x's right here on the x squared. So I'm going to completely cancel out that x squared with both of these x's right here at the same time. So check it out. Boom, boom. The x squared up on top is now gone, and this x are now gone. What else do I have? Well, I have z's on top and z's on the bottom. So I'm going to cancel out. How many z's do I have up on top? This one right here and this one right here. I want to cancel out both of these, and there's 3 of them on the bottom. So I want to cancel out 2 of these on top with 2 of the ones that are on the bottom. So look, these 2 disappear, and these 3 become 1 because 2 canceled with 2. There's only 1 left. And of course, the y's, well, there's 1 y left right here. Right here, there's 1 y left in the denominator, and there's 2 y's up on top. So one of these cancels out with one of these. So there's still going to be a y left up on top. So the y cancels out with that, and there's 1 left up on top. So what's our final answer? Well, we have a 4 on top. We have a y to the 1. You could just say y. And you also have an x to the 4th. So if we write it in order, it's going to be 4x to the 4th y. And it's going to be over whatever's left over on the bottom, which is simply a z to the 1 and a 5. So you're going to write it as 5z. You guys got it? Okay, let's move on to number 3. This one's a little bit more fun. What could we do here? Well, we could factor. So I'm going to rewrite both fractions. And I'm going to take a look at the top left. And what could I factor out of here? 3x. Thank you very much. And what's going to be left if I factor out a 3x? 1 minus x. Now that's a little funky because we have a 1 and then an x when usually we have the x first and the 1 second. We could actually replace that. We could even do that right now. I know this might be confusing to some people, but I want to rewrite this as a minus x plus 1 instead of 1 minus x. So I'm going to switch it, make it a minus x plus 1. That minus sign belongs to the x. So I'm just going to rewrite it as minus x plus 1. Whoops. That's not what I wanted to do. Okay, I won't rewrite it. I'll rewrite it in a little while. Sorry. Let me just continue factoring. How about the bottom left? What could I factor that to? X plus 5x minus 1. And how about the top right? Plus 5 minus 4. And on the bottom I have a 3x. Okay, so now let's cancel things out. the x plus 5 up here and the x plus 5 down there. The 3x up here and the 3x down there. And what do we have left? We have a 1 minus x, which I'm going to switch now. I'm going to make it look like negative x plus 1. And on the bottom, I still have the x minus 1. And I also still have a multiplication and this other fraction of x, that's a minus 4, it looks like a times 4, sorry, over 1. Okay, so what else could I cancel? Could I cancel out anything else? You see how we have a minus x right here and a positive x right here? A positive 1 up here and a negative 1 down here? We know that they're complete opposite values. So if I want to make them look the same, I could pull out what? A negative 1. So if I pull out a negative 1, what will happen to the inside of the parentheses? If I pull out that negative 1, the inside of the parentheses is going to become positive x and a negative 1. Does that make sense? So I really will have, it got ugly. Let me rewrite everything. So there it is on the side, negative 1 times x minus 1. On the bottom, we still have the x minus 1, and we still have this part over here, which is x minus 4 over 1. So, of course, we could now cancel the x minus 1 up on top with the x minus 1 on the bottom, and your final answer, number 3, will be a negative 1 on the outside with the x minus 4 on the inside. That's your final answer, or you could rewrite it as negative x plus 4. It's completely up to you. Got it? Question? And now for the last one, whoa. For the last one, we're going to flip the second fraction, and I'm going to rewrite the first one without moving anything. And the second fraction, I'm going to flip. Change it to multiplication. It was division. I'm going to change it to multiplication. But what I'm going to do is I'm going to factor this bottom one and write it up on top. So I'm going to write the factored form of the bottom one up on top, which will be up here. So I end up with what? What times what is 30? That if I add together is negative 11. Negative 5 and negative 6. Okay? And if I factor this guy and rewrite in the denominator, what do I get? X on the outside, x minus 6 on the inside. And now let's cancel things out. X minus 6's cancel. Oh, wait a minute. I forgot to factor the denominator over here on this side. What could I factor out of here? Factor out a 2 right there. So then I could cancel the x minus 5 up here with the x minus 5 down there. This was already gone because I rewrote it as 2 times x minus 5. So what's left over? 7x is on top. And down here we have a 2 and an x. So before I write my final answer, this x up here could cancel out with that x down there. Scratch it, scratch it. There's your final answer, which is just 7 over 2. Boom. That was a class opener. That's kind of like a review from last section. Let's move on to something different today. Adding and subtracting rational expressions. It's really easy to add or subtract fractions. Okay? We all know that we need to have a common denominator in order to add or subtract fractions. So in other words, I like to rewrite two fractions but write the common denominator down here on both of them. So 7, I'm going to change it to become 14, and 14 is already 14. The question is, how do I change 7 to become 14? Times 2, so what you do to the bottom, you do to the top. I'm going back to the 4th grade here, reviewing how to add simple fractions. So I end up with 4 over 14. And the 14's over here is already 14, so I don't do anything to it. So 3 is what I have up on top. And now that I have a common denominator, what do I do with the numerators? Add them together and I get my final answer, what? 7 over 14. But that could be reduced down to 1/2. Anytime you have a fraction that you could reduce, you might as well reduce it. Anytime you have a fraction you could simplify, you might as well simplify it. Let's try number 2. However, I want you guys to think differently. I already know that you guys know that the denominator is what? The common denominator. 6, right? But instead of writing 6, let's leave it as 2 times 3. 2 times 3. Okay? I know you're probably thinking, why? Why do I want to do that? It'll help us out in a couple of minutes when we get to the next video, actually. So how do I go from a 2? How do I change this 2 to look like a 2 times 3? Well, I multiply it by 3. Exactly. And what you do to the bottom, you do to the top. So you end up with a 3 up here. And how do I change the 3 to look like a 3 times 2? Well, you multiply it by 2. So you multiply it by 2 and you end up with a 2 up here. And now you have a common denominator. Now you're able to subtract the top with the top. Right? So 3 take away 2 is 1. And that's your final answer. 1 over the common denominator, 2 times 3. But we all know that that's really 1/6. Yay? Got it? Okay, now you're probably thinking, why? Why do I want to do it that way? Well, it'll help you out in the future. Like if we jump to this one up here, where we have variables. We don't have a common denominator. How's this going to work out? Well, I have this denominator and this denominator. They are not the same. I cannot add the numerators because they're not the same. I need a common denominator. What is the common denominator? And where do I get it from? The common denominator will be this guy times this guy. Does that make sense? Kind of like when I had a 3 right here and a 2 right there, my common denominator is 6. And how did I get 6? Well, I multiplied this guy times this guy. So that's what we're going to do here. We're going to take both of these guys and multiply them together to get the common denominator here and here. But you know what? I'm not even going to multiply them. I'm just going to rewrite them right here and rewrite them right here with multiplication between them. Bear with me, guys. So this is going to be a x plus 3 times x minus 2. And again, x plus 3 times x minus 2. Does that make sense? And again, I want to go back and say, what did I do to the x plus 3 to get an x plus 3 times x minus 2? I multiplied by what? By x minus 2. And what I do to the bottom, I have to do to the top. So I need to multiply this one by x minus 2. And of course, we're going to distribute 2 times x and 2 times negative 2. So what do I get as my new numerator of the left fraction? 2x minus 4. Okay? And what do I get for my new numerator on my right side? Well, actually, before answering that, how do I change from an x minus 2 to get an x minus 2 times x plus 3? Exactly, multiply it times x plus 3. So multiply the top also by x plus 3. And when you distribute, what's our new numerator going to be? X squared plus 3x. Ladies and gentlemen, now we're ready to add the numerator with the numerator because we have a common denominator and a common denominator. So when I actually add the numerator with the numerator, it's really just combining like terms. So what I'm really going to end up combining is the 2x right here with the plus 3x right there. So let me rewrite my whole fraction. My final answer is going to be, of course, we have the common denominator on the bottom, x plus 3, x plus 2. And on top, I'm going to start with the highest degree exponent, the x squared. I'm going to write that down, x squared. And then when I combine the 2x with the 3x, I get 5x. And last but not least, we write down that minus 4 at the end. The minus 4 that we had over here. Write it down right there. And of course, you're supposed to try to reduce that fraction. Try to factor the top and cancel. But you can't, so that is your final answer. Yeah, wait a minute. So the x plus 2, I just made that up. Because as you can see, the common denominator is x plus 3 times x minus 2. So I apologize. This should not be x plus 2. It should be a x minus 2 on your final answer. I messed up. Sorry. So it's x plus 3 times x minus 2 on the bottom with the x squared plus 5x minus 4 up on top. Does that make sense?